No, the ground fault circuit interrupter breaker is not required in the main panel in this scenario. Because the ground fault circuit interrupter breaker is being installed in the subpanel, it offers protection for both the subpanel and all downstream circuits connected to it. This means the ground fault circuit interrupter in the subpanel will detect ground faults or imbalances in the current, triggering the breaker to trip and protecting both the subpanel and the recreational vehicle connected to it. Furthermore, since double insulated cable, referred to as DB cable, is used to connect the main panel to the subpanel, bonding the subpanel is unnecessary. The double insulated cable provides its own ground path, thus removing the requirement for a separate bonding jumper. In summary, replace the existing 20 amp ground fault circuit interrupter breaker in the main panel with a 60 amp single pole breaker. Ensure a breaker blank is installed to fill the space vacated by the removed ground fault circuit interrupter breaker. Use double insulated cable to make the connection between the main panel and the subpanel. Verify a ground fault circuit interrupter breaker is installed within the subpanel to protect the recreational vehicle and the circuits it supplies. This setup should provide the required protection and proper operation for a recreational vehicle electrical system while adhering to all relevant electrical codes. Now, let's elaborate on ground fault circuit interrupters, double insulated cables, and subpanel configurations. A ground fault circuit interrupter, abbreviated as GFCI, is a safety device designed to protect people from electrical shock. It works by monitoring the current flowing through a circuit. If there is an imbalance between the outgoing and returning current, it indicates that some current is leaking to ground, which could be through a person. The ground fault circuit interrupter then quickly trips the circuit, cutting off the power and preventing a potentially fatal shock. Ground fault circuit interrupters are typically required in areas where water is present, such as bathrooms, kitchens, and outdoor locations. Double insulated cable, also known as DB cable, is a type of electrical cable that has 2 layers of insulation. This provides an extra level of protection against electrical shock. The double insulation eliminates the need for a separate grounding conductor in some applications, as the cable itself provides a path for fault current to flow back to the source. It's crucial to check local electrical codes for specific requirements on when and where double insulated cable can be used. A subpanel, also called a distribution panel, is a secondary electrical panel that receives power from the main electrical panel and distributes it to various branch circuits. Subpanels are commonly used in situations where there are many circuits or where the main panel is located far away from the loads being served. When installing a subpanel, it's essential to follow proper wiring and grounding procedures. The neutral and ground conductors must be kept separate in the subpanel, and the subpanel enclosure must be grounded to the main panel. Bus isolation refers to the separation of the neutral and ground buses within the subpanel. This separation is necessary to prevent circulating currents and ensure proper operation of the ground fault circuit interrupter protection. Now, let's address several key considerations related to your specific situation. Firstly, determining the appropriate breaker size for the subpanel feed is paramount. While a 60 amp breaker is suggested, it is vital to ensure this amperage aligns with the calculated load of the recreational vehicle subpanel and the ampacity of the wire being used. Referring to the National Electrical Code, specifically Article 220, will guide you through the process of calculating the load. The calculated load should include all anticipated loads that the RV might draw simultaneously. Secondly, when using double insulated cable, it's essential to verify its suitability for underground or outdoor use, depending on the installation environment. Double insulated cable is often rated for direct burial, but confirming the specific cable's rating ensures compliance with safety standards. Thirdly, ensure the 30 amp and 20 amp ground fault circuit interrupter breakers within the recreational vehicle subpanel are properly sized for their respective circuits. Overcurrent protection must match the ampacity of the conductors they protect. Remember to test these ground fault circuit interrupter breakers monthly to ensure they are functioning correctly. This is usually accomplished by pressing the test button on the breaker. Fourthly, when you replace the 20 amp ground fault circuit interrupter breaker with a 60 amp standard breaker in the main panel, ensure the original ground fault circuit interrupter breaker was not serving any other critical functions that necessitate ground fault protection. Circuits serving outdoor receptacles or those near water sources often require ground fault protection as per code. Fifthly, double insulated cable typically has a green insulated grounding conductor. Connect this conductor to the ground bus in both the main panel and the subpanel. Even though the subpanel's neutral and ground buses are isolated, maintaining a continuous equipment grounding conductor is essential for safety. Sixthly, the breaker blank used to fill the empty space in the main panel must be of the correct type and rating for the panel. Using the wrong type of blank could leave exposed energized parts or compromise the panel's integrity. Seventhly, it is important to torque all breaker connections to the manufacturer's specifications. Loose connections can cause overheating and potentially lead to a fire. Use a calibrated torque wrench to ensure accurate and consistent torque. Eighthly, make sure to label the subpanel clearly, indicating its purpose and the circuits it serves. This will aid in future troubleshooting and maintenance. Ninthly, local electrical codes may have specific requirements regarding recreational vehicle installations. Contacting a licensed electrician or the local electrical inspector will provide clarification on any local amendments or regulations. Tenthly, remember that electrical work can be dangerous. If you are not comfortable performing these tasks yourself, hire a qualified electrician to ensure the work is done safely and correctly. It's always best to err on the side of caution when dealing with electricity. Now, let's explore some potential issues and troubleshooting tips related to recreational vehicle subpanels. Firstly, if the ground fault circuit interrupter breaker in the subpanel trips frequently, this could indicate a ground fault in one of the recreational vehicle circuits. Disconnecting appliances one by one can help isolate the faulty device. Secondly, if the voltage at the recreational vehicle subpanel is consistently low, this could be due to an undersized feeder conductor or a loose connection in the main panel or subpanel. Check the voltage at the main panel to rule out problems with the utility supply. Thirdly, if lights flicker or dim when appliances are turned on, this could indicate an overloaded circuit. Distribute the load more evenly across different circuits or upgrade the circuit capacity. Fourthly, if the recreational vehicle subpanel is exposed to the elements, ensure it is properly protected from rain and moisture. Water can damage electrical components and create a shock hazard. Fifthly, if the recreational vehicle subpanel is located in a high-traffic area, consider installing a protective barrier to prevent accidental damage. Sixthly, if you are using a generator to power the recreational vehicle subpanel, ensure the generator is properly grounded and sized to handle the load. Overloading the generator can damage it and potentially create a fire hazard. Seventhly, if you are storing your recreational vehicle for an extended period, disconnect the power supply to the subpanel to prevent phantom loads from draining the battery. Eighthly, if you notice any signs of corrosion or damage to the electrical components in the recreational vehicle subpanel, replace them immediately. Corrosion can weaken connections and increase the risk of electrical failure. Ninthly, if you are unsure about any aspect of the recreational vehicle electrical system, consult a qualified electrician. It's always better to be safe than sorry when dealing with electricity. Tenthly, remember to keep a record of all electrical work performed on the recreational vehicle subpanel, including dates, descriptions of the work, and any parts replaced. This will help with future troubleshooting and maintenance. It is important to reiterate the importance of following all applicable electrical codes and safety guidelines when working with electrical systems. Improper wiring or installation can create a serious safety hazard. If you are not comfortable performing the work yourself, hire a qualified electrician. Let's further clarify specific points regarding ground fault circuit interrupter protection. The National Electrical Code, in section 210.8, outlines where ground fault circuit interrupter protection is required. In general, ground fault circuit interrupter protection is required for 125-volt single-phase 15 and 20 amp receptacles in locations such as bathrooms, kitchens, garages, outdoors, and unfinished basements. Recreational vehicles are considered dwelling units, so these requirements typically apply to their electrical systems as well. Therefore, the ground fault circuit interrupter breakers in the recreational vehicle subpanel are essential for protecting occupants from electrical shock. It's important to note that ground fault circuit interrupter protection is not a substitute for proper grounding. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. The equipment grounding conductor, typically a green or bare wire, connects the metal parts of electrical equipment to the grounding bus in the electrical panel. This ensures that any fault current will flow back to the source and trip the breaker, protecting people from electrical shock. Double insulated appliances do not require a connection to the equipment grounding conductor. These appliances have 2 layers of insulation, which provide a high level of protection against electrical shock. However, even with double insulated appliances, it's still important to have ground fault circuit interrupter protection in areas where water is present. In addition to ground fault circuit interrupters, there are also arc fault circuit interrupters, RFCIs. Arc fault circuit interrupters protect against fires caused by arcing faults. An arcing fault is an unintentional electrical discharge between 2 or more conductors. Arc fault circuit interrupters are typically required in bedroom circuits to protect against fires caused by damaged cords or faulty wiring. Another important aspect of electrical safety is proper overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, protect against overloads and short circuits. An overload occurs when too much current flows through a circuit, which can cause the wires to overheat and potentially start a fire. A short circuit occurs when there is a direct connection between 2 or more conductors, which can cause a large surge of current and damage to electrical equipment. Circuit breakers and fuses are designed to trip or blow when an overload or short circuit occurs, cutting off the power and preventing damage. It's crucial to use the correct size circuit breaker or fuse for each circuit. Using an oversized breaker or fuse can allow too much current to flow, which can damage the wires and potentially start a fire. The size of the breaker or fuse should be matched to the ampacity of the conductors it protects. Conductor ampacity is the maximum amount of current a conductor can safely carry without overheating. Conductor ampacity is determined by factors such as the size of the conductor, the type of insulation, and the ambient temperature. The National Electrical Code provides tables that list the ampacity of different types of conductors. When selecting conductors for an electrical circuit, it's important to choose conductors with an ampacity that is sufficient to handle the expected load. It's also important to consider voltage drop, which is the decrease in voltage that occurs as current flows through a conductor. Voltage drop can cause lights to dim, motors to run slower, and other electrical equipment to malfunction. To minimize voltage drop, use larger conductors or shorten the length of the circuit. Now let's delve deeper into the specifics of recreational vehicle electrical systems. Recreational vehicles typically have 2 electrical systems, a 120-volt alternating current system and a 12-volt direct current system. The 120-volt alternating current system is used to power appliances such as air conditioners, refrigerators, and televisions. The 12-volt direct current system is used to power lights, pumps, and other small appliances. Recreational vehicles are typically equipped with a shore power connection, which allows them to be connected to an external power source, such as a campground electrical outlet. This shore power connection is typically a 30 amp or 50 amp receptacle. When connected to shore power, the recreational vehicle's electrical system is powered by the external power source. Recreational vehicles are also typically equipped with a generator, which can be used to power the electrical system when shore power is not available. The generator is typically a gasoline or propane-powered unit. When the generator is running, it provides power to the recreational vehicle's electrical system. Recreational vehicles are also typically equipped with a battery, which is used to power the 12-volt direct current system when shore power and generator power are not available. The battery is typically a lead-acid battery. When the battery is being used, it provides power to the 12-volt direct current system. Recreational vehicle electrical systems can be complex, so it's important to understand how they work. If you are not comfortable working on your recreational vehicle's electrical system, consult a qualified electrician. In addition to the topics already discussed, it is important to consider surge protection for your recreational vehicle. Power surges can damage sensitive electronic equipment such as televisions, computers, and refrigerators. Surge protectors are designed to protect against power surges by diverting excess voltage away from the equipment. There are two main types of surge protectors: whole recreational vehicle surge protectors and point-of-view surge protectors. Whole recreational vehicle surge protectors are installed at the main electrical panel and protect the entire recreational vehicle from power surges. Point-of-view surge protectors are plugged into individual outlets and protect only the equipment plugged into that outlet. It's a good idea to use both types of surge protectors to provide comprehensive protection for your recreational vehicle. When selecting a surge protector, look for one with a high surge current rating. The surge current rating indicates the maximum amount of current the surge protector can handle. A higher surge current rating provides better protection against large power surges. It's also important to select a surge protector with a good warranty. A good warranty indicates that the manufacturer stands behind their product. In addition to surge protection, it's also a good idea to use a voltage regulator to protect your recreational vehicle's electrical system. Voltage regulators help to maintain a stable voltage supply to the equipment. This can be especially important when using a generator, as generators can sometimes produce fluctuating voltage. Fluctuating voltage can damage sensitive electronic equipment. Voltage regulators are available in a variety of sizes and types. Choose a voltage regulator that is appropriate for your recreational vehicle's electrical system. Let's further discuss the relevance of the National Electrical Code, or NEC, in ensuring electrical safety. The NEC is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. While not a law itself, it is often adopted by state and local jurisdictions, making it a legal requirement. The NEC is updated every 3 years to reflect changes in technology and best practices. It covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. When working on any electrical project, it's essential to follow the requirements of the NEC. This will help to ensure that the work is done safely and correctly. The NEC is a complex document, so it's often helpful to consult with a qualified electrician to ensure compliance. The NEC also provides specific requirements for recreational vehicle electrical systems. These requirements cover topics such as wiring methods, grounding, and overcurrent protection. Following the NEC requirements for recreational vehicle electrical systems will help to ensure the safety of the occupant. Some key sections of the NEC that are relevant to recreational vehicle electrical systems include Article 551, which covers recreational vehicles and recreational vehicle parks, Article 220, which covers load calculations, and Article 250, which covers grounding and bonding. In addition to the NEC, there may be other local codes and regulations that apply to electrical work in your area. It's important to check with your local building department to determine what codes and regulations are in effect. The local building department can also provide guidance on permitting and inspection requirements. Obtaining the necessary permits and inspections is essential to ensure that the electrical work is done safely and correctly. Permits and inspections help to verify that the work complies with applicable codes and regulations. It's also important to keep accurate records of all electrical work performed on your recreational vehicle. These records should include the date of the work, a description of the work performed, and any parts replaced. Keeping accurate records will help with future troubleshooting and maintenance. If you ever sell your recreational vehicle, these records can also be valuable to the new owner. Proper maintenance of your recreational vehicle's electrical system is essential for safety and reliability. Regularly inspect the wiring, connections, and equipment for any signs of damage or wear. Replace any damaged or worn components immediately. Clean the electrical panels and equipment regularly to remove dust and debris. Dust and debris can accumulate and cause overheating. Test the ground fault circuit interrupter breakers monthly to ensure they are functioning correctly. If a ground fault circuit interrupter breaker trips frequently, investigate the cause and correct the problem. Don't simply reset the breaker without addressing the underlying issue. Periodically check the voltage at the electrical outlets to ensure that the voltage is within the acceptable range. Low voltage can damage sensitive electronic equipment. If you notice any unusual smells or noises coming from the electrical system, investigate the cause immediately. Unusual smells or noises can indicate a serious problem. By following these maintenance tips, you can help to keep your recreational vehicle's electrical system in good working order and ensure the safety of the occupants. Let's now address specific considerations for grounding and bonding in recreational vehicle electrical systems. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Bonding connects the metal parts of electrical equipment together to create a low impedance path for fault current. In a recreational vehicle, the chassis is typically used as the grounding electrode. The grounding electrode is a conductive object that is connected to the earth and provides a path for fault current to flow to ground. The chassis must be properly bonded to the electrical system to ensure that it is a good grounding electrode. The equipment grounding conductor, typically a green or bare wire, connects the metal parts of electrical equipment to the grounding bus in the electrical panel. This ensures that any fault current will flow back to the source and trip the breaker, protecting people from electrical shock. In a recreational vehicle, the equipment grounding conductor must be connected to the chassis. The neutral conductor is the conductor that carries the return current from the load back to the source. In a recreational vehicle, the neutral conductor must be isolated from the chassis except at the main electrical panel. This is to prevent circulating currents and ensure proper operation of the ground fault circuit interrupter protection. Circulating currents can cause the ground fault circuit interrupter breaker to trip unnecessarily. The grounding and bonding requirements for recreational vehicle electrical systems are complex, so it's important to consult with a qualified electrician to ensure compliance. In addition to the grounding and bonding requirements, it's also important to follow the other electrical safety guidelines discussed in this narration. By following all of the electrical safety guidelines, you can help to protect yourself and others from electrical shock and fire. Now let's discuss the different types of electrical panels that are commonly used in recreational vehicles. There are two main types of electrical panels: circuit breaker panels and fuse panels. Circuit breaker panels use circuit breakers to protect against overloads and short circuits. Circuit breakers are reusable devices that trip when an overload or short circuit occurs. Fuse panels use fuses to protect against overloads and short circuits. Fuses are one-time use devices that blow when an overload or short circuit occurs. Circuit breaker panels are generally preferred over fuse panels because they are more convenient to use. When a circuit breaker trips, it can simply be reset. When a fuse blows, it must be replaced. Circuit breaker panels are also generally more reliable than fuse panels. Fuses can sometimes blow for no apparent reason. When selecting an electrical panel for your recreational vehicle, choose one that is appropriately sized for your electrical needs. The electrical panel should have enough circuits to accommodate all of the electrical loads in your recreational vehicle. The electrical panel should also be rated for the appropriate voltage and amperage. In addition to the electrical panel, it's also important to select the correct size and type of wiring for your recreational vehicle. The wiring should be sized to handle the expected load. The wiring should also be appropriate for the environment in which it will be used. For example, if the wiring will be exposed to the elements, it should be rated for outdoor use. When selecting wiring for your recreational vehicle, consult with a qualified electrician to ensure that you are using the correct size and type of wiring. Finally, it's important to have your recreational vehicle's electrical system inspected by a qualified electrician on a regular basis. Regular inspections can help to identify potential problems before they become serious. Electrical inspections can also help to ensure that your electrical system is in compliance with all applicable codes and regulations. By following these guidelines, you can help to ensure the safety and reliability of your recreational vehicle's electrical system. Remember that electrical work can be dangerous. If you are not comfortable performing these tasks yourself, hire a qualified electrician to ensure the work is done safely and correctly. It's always best to err on the side of caution when dealing with electricity.